Hi, we're back. Um, I already recorded this video once before and had my mic on mute. So here we go again. We're gonna record it again, and well, that's what quality assurance is for, right? In today's video, we want to look at how to move AI objects that you created through SimConnect in Flight Simulator 2024. Um, and there's a twist with that. We'll get back to that later on in the video. I wanted to start off with a little demo to see what we achieved with this code I'm trying to explain to you. So let's go and do that. So you can see my screen here. I started a flight on an airport in the Netherlands. This is Lelystad Airport, an airport I'm familiar with. I lived close by for a couple of years, and it's really suitable for our demo. So in the screen you see the tool I'm writing. This is FS runway incursions. I hope to release this somewhere in the next 1 or 2 months. And the goal is to have random runway incursion events on your flights. Right now I have I set this up like this. These are the settings so that on a departing airport there will always be an animal on the runway. We have a list of animals that you can choose from. It'll pick one of these selected animals. We'll get back to that later on in the video. Right now, what we want to do is click the connect button, and it will create a bunch of animals on the runway. You can see one right there in the distance, another one over there. And if we move closer, so we're gonna just taxi over there. Just a bit of a high-speed taxi, I guess, because we don't want to be waiting too long. We're going to see that these animals will start moving. They will try to move away from us. It's kind of cool. And I guess that's also what animals will do in real life. I guess they will try to flee away from an aircraft because they don't know this. And it's moving. It's slow, but it's moving. So here we go. They are moving, and that's all we want to show. These animals aren't that fast. So that's what we built, and I want to explain the code to you. I'm actually going to stop the tool. It all starts with this function right here, which actually captures the aircraft position changed event from our simulator class. If you've seen my previous videos, I split the code up in two parts. There's the simulator class, which actually handles all the communication with SimConnect, and there's the incursion logic class, which deals with any application logic. In this case, this event is triggered whenever the position of the player aircraft is changed. And what I want to do is check, well, first of all, I want to set the state to monitoring this flight. It's not that important. I'll update the location whenever something like that happens, except for if the well, in this case, this part of the code is what we're using right now. We're checking whether we're on the ground. In that case, we want to update the location as well. And in either of these cases, we'll try and move our objects. Go into this function. As you've seen in the previous video about creating objects, if you haven't seen it, I'll include a link. The managed objects, this is a collection, keeps track of all the objects that were created by the app through SimConnect, which is important, amongst other things, so you can actually do something with these objects. We'll look through these. We'll actually calculate the distance from the particular object, latitude, longitude, altitude, compared to the player location. Again, coordinates and the altitude of sea level. And we'll get a distance back in meters. And if that distance is greater than the trigger distance in meters for this particular object, we'll just skip it because it's too far away. We don't have to do anything with it. But if the object is actually within range, we'll continue. And we'll actually check whether or not this object is already moving. So we don't want to keep spamming it with new move instructions. The reason why will become clear in a little bit. And we also have this finished moving by. This is datetime offset, which basically means we have some datetime, some point in time that this thing, we expect this object to finish moving. Now, if it was moving and this finishes moving by time has passed because it's smaller than the UTC now, we actually know it's no longer moving. So we want to just mark it as it's not moving, and then we just continue. Can we update the application state so the user can see what's happening to controlling AI objects? And then this thing is interesting. We generate a path. This is every managed object that we create. We have a path generator assigned to it, and the path generator can generate a path. It will spit out an enumerable of waypoint objects. In this case, we pass in the object that we want to move. We pass in 100, which is the number of waypoints. No, sorry, that's the distance that we want to travel. In this case, 100 meters. And the location we want to move away from. We'll get back to this function in a little bit once we complete the rest of this code. All these waypoint objects also have a time from previous waypoint in seconds. So between waypoint 0 and 1, you'll take X seconds to travel that distance. And because we have that for all our waypoints, we can actually calculate the time it will take to travel this path. Which we'll use to set the finishes moving by, which we used earlier, to set this time. So that's good. And then we'll mark it as is moving. So next time around, we won't be moving it again unless it's being reset to false again. And then there is the location that will update to the last waypoint, because once this is finished, we know it will be at this location. We also will make sure that the altitude above sea level will be set to this managed object altitude, which is the altitude of the managed object that we actually retrieved earlier. This might seem like a weird thing to do, but there's plans for this for the future. And then finally, we're going to set the movement. So the set object movement is on the simulator class. So we pass in an object ID, which is the ID of the object that we created earlier. And we pass in this enumerable of waypoints. So let's dive into this function. It is a couple of things. First, it actually converts these waypoint objects to SimConnect data waypoint structs. This is a struct. I like to do this with link, user select, and then just create a struct for each of these objects and then assign the properties I need. In this case, we want to set some flags. They have to be on the ground. These animals do not fly. They have to obey our speed for each of the waypoints. So we set the speeds and then the location of the waypoint. And then at the end, we actually cast this into an array because we need an array of these structs. Then finally, we create a object array In this case, we call it data. We copy all of these structs into this array, and then that data, this object array, is passed into the set data on sim object. Because the set data on sim object does not understand SimConnect data waypoint array, so we have to actually convert it into this object array and then pass that into this call. You cannot just say, okay, I just cast this thing and then pass the pointer to the waypoints array, because it will break. A couple of things. I have this data definition. We'll have a look at that next. Obviously, you want to pass in the object ID. This is the object we're going to move, and these are of this default flag is just fine. And then this is the data, the waypoints that we want the object to use for moving. This data definition, I'll just do final references and then go here. This is quite important, actually. We use an add to data definition, which is a separate data definition that we defined. The sim object move data is what I called it, which is our number 2 in this case. And I'll just bring up this little IntelliSense helper. The datum name is AI waypoint list. The unit's name is number, which is a bit strange, but that's how it works. And then the data type is a SimConnect data type dot waypoint. And the epsilon is 0, and the datum ID is SimConnect and used as most other users do. But this AI waypoint list and this number and this waypoint, these are important for your data definition. You need those. So yeah, that was the SimConnect side of things. I go back here. And I promised to show you something about paths. So let's look into this generate path. This path generator, I chose to make an interface iPath generator because I plan on implementing different path generators, not just for animals, but also in the future for ground vehicles. So if I go to the implementation here, you can see that, well, we have the parameters already. We talked about it already. The managed object is the object we actually want to generate a path for, the distance we want to travel, and the point we want to travel away from. Well, if the location of the managed object itself is null, we obviously cannot do a thing. So we'll just enumerate an empty enumerable, and then if we do have location, first thing we do is we actually calculate the heading that we want to move. In this case, for this straight line path generator, which is a very basic implementation, we just get a heading away from the away location based on the location we're at right now. By the way, if you're interested in any of the math behind this, please leave a comment, and maybe we can do a video diving into some of the math. In the FS Runway Incursions app, there's some quite interesting stuff in there, so let me know if you are interested in that. So yeah, we have the heading, and then we set this remaining distance variable to whatever distance we want to travel, because we're going to deduct distances between waypoints from it to make sure we get the right distance in the path. And we calculate this in 2 phases. The first phase is the acceleration phase. We want to make it a little bit realistic. We're experimenting with, okay, this animal will need some time to get up to speed. So the acceleration phase takes care of that. So first we calculate the distance we would need to come from a standstill to the top speed of this particular object, which is the calculation you can see in the screen. And then we use that to actually calculate a bunch of waypoints 1 meter at a time. which you can see in this loop. And for each meter, we calculate the distance that we would have traveled with the speed that we traveled in that 1 meter, which happens here. And then, so first we calculate the speed, then we, if we're not reached, if we have reached the top speed, then that's the speed that we're going to go for. If not, it's just the outcome of this calculation. And then we're going to say, okay, give me a point from the object location, the number of meters away in the heading that we calculated with the speed that we calculated, and then we calculate the time it takes to travel that distance, and then we deduct that 1 meter distance. So this, the speed increases over the number of waypoints that we calculate here. And then once we're up to speed, we calculate the waypoints for the rest of the path, which is a little bit easier to do. And then at the end of this, we have a nice list of waypoints. So this is a little bit abstract, and I was like, okay, how am I going to test this specifically with a little bit more complicated stuff I want to test out later on? So I built a little tool, which I want to show you, which is this path visualizer. So I'll just, let me just start that up real quick. It's well, the UI is very basic right now, but if we need to, we can always improve on that. If I click this button, it will generate a path based on what we did earlier. Let me just make this a little bit bigger. And you can show that, you can see that this is the point we're moving away from. This is the object we're moving with a little arrow that points in the direction that the object is traveling in. And if you hover over it, that's what you can see. That's the location for this object with the heading it was facing, and then the next waypoint with the speed it will be doing, and then this is still through an early phase, and then finally it will just start doing these 10-meter steps. And then, this is the path that is it generated. So we can actually look at this instead of trying to figure this out in Flight Simulator while running complicated test scenarios. I figured this was a little bit easier to use for this particular testing. If you're interested in this tool, or for whatever reason, maybe you're facing a similar problem, leave a comment and maybe we can figure out a way to share this. Because happy to share this with the community if anyone is interested. That being said, that was what I wanted to show to you, except for one other thing, which I'll switch over back to the app. I showed you earlier that in this settings screen, we have these 5 animals. And while I was fighting with this moving sim objects through SimConnect, I ran into an issue. And these first 3 objects, they worked fine. These were all created by a Sobo. Somebody is really fascinated by bears because these are the only ground animals in there in the Sobo set, so it's a bit odd. But once I started using other animals, which are created, or I guess they were borrowed from another product by Microsoft, they would not move with the same code. In fact, I have not been able to write any code that would move those animals. I've been on forums, I've been on Discord to try and figure out why this doesn't work. The only answer I got was, that you have to do some trickery with SimConnect variables, but still, I didn't get any of those animals to move with the code I have, or with any other code for that matter. But I was able to get other animals from this third-party package for free that actually do move. I wanted to give a shout out to this package that I found online. Let me just quickly see my downloads right here, which is this package. The animated human 3D models library. And you think, hey, this is about humans, but in fact, there's quite a bunch of animals in here. Oh, pretty nice models, like as you can see in the screenshots right here. And I installed those on my laptop, and I'm perfectly able to just use those. So I added some code into FS Runway incursions to detect if models from this package have been installed, and if they have, then they will show up in settings. For now, I limited to 2 because I haven't done any further testing, and I need to dig up some other data on them before I can actually include them. But so far, it's looking really good. So big shout out to SuperSpot for creating this package. I also messaged him, and he came back to me pretty quickly. So yeah, he's done quite a lot of stuff for Flight Simulator already for our community, and just wanted to make sure that you guys know about it. So if you intend to maybe install FS Runway incursions later on, and you want to have a little bit more variety in animals, just install this one, Animated Human 3D Models Library. I will also leave a link in the description. Yeah, and with that shout out, we're pretty much done. I just wanted to say a big thank you for watching. There's been great interest in the SimConnect videos. If there's anything in particular you want to see, again, leave a comment, leave a like, subscribe. That will be very much appreciated. And I hope to see you next time.